Hello everybody. In this video we are going to be looking at the solution to the honors refraction due now number 2. That's the last time I'm going to be able to do that to you guys. I know you're going to miss it. You're really going to miss it a lot. I'm going to miss doing it to you. I know you're going to miss me doing it to you. Oh, you know what? If you ever at college for you seniors or next year, if you really do miss it, just send me an email and I'll send you a reply in all caps or something like that. We'll work around it just in case you need a little dose of me yelling at you. All right, let's take a look at our problem. We have a ray of light that is incident on the surface of a block of clear ice at an angle of 40 degrees with the normal. Part of the light is reflected and part of the light is refracted. Find the angle between the reflected and refracted light. So we are given my initial angle of incidence of 40 degrees. I know that the index of refraction for air is 1.00. And I know that my index of refraction for ice is 1.309. And we can always get that from the table of indices of refraction from the PowerPoint or from the formula sheet that is posted in the toolbox on the website. So what are we trying to find in this problem? Well, if we look at the diagram here, this is my incident ray of light coming in here and making that 40-degree angle with the normal. Part of that ray is reflected back into the air. So part of the ray gets reflected back into here. And this is going to be my angle of reflection, which we will call phi for now. Part of the ray is then going to be refracted into the ice. And my angle of refraction, I'm going to call theta 2. What they're asking us to find in this problem is the angle between my reflected ray and my refracted ray, which I'm going to call angle alpha, just because I need another Greek letter for naming all these angles. So this is the one that we are trying to find. So the first thing we need to do is find phi, or my angle of reflection. And to find the angle of reflection, I need to use my law of reflection. And I know that my law of reflection states that the angle of incidence equals the angle of reflection. So if my angle of incidence is 40 degrees, my angle of reflection is also 40 degrees. So I know that phi here is going to be 40 degrees. Now to find my angle of refraction, theta 2, I will need to use Snell's law. So using Snell's law and solving Snell's law for theta 2 is going to give me theta 2 equals the inverse sine of n1 times sine theta 1 divided by n2. I insert my index of refraction for air, my angle of incidence, and my index of refraction for the ice, and that will give me an angle of refraction of 29.4 degrees, which is this angle there. Now, because both the angle of reflection and the angle of refraction are both measured from the normal, I know that the angle between the reflected ray and the refracted ray is going to be 180 degrees minus the angle of reflection minus the angle of refraction, because my normal is a straight line, so that's 180 degrees. So 180 degrees minus 40 degrees minus 29.4 degrees will give me an angle between the reflected ray and the refracted rays of 111 degrees. Problem number 2. The laws of reflection and refraction are the same for sound as they are for light. The speed of sound is 340 meters per second in air and 1,510 meters per second in water. If a sound wave traveling in air approaches a plain water surface at an angle of incidence of 12.0 degrees, what is the angle of refraction? So we are given the speed of the sound wave in air, 340 meters per second. I'm given the speed of the sound wave in water, 1,510 meters per second. I am given the angle of incidence in the air of 12.0 degrees, and I'm being asked to find the angle of refraction once the sound wave enters the water. If I'm dealing with an angle of refraction, I know I'm going to want to use Snell's law. So here is Snell's law. But you may notice that Snell's law does not have any velocities in it, and we are given velocities. So we need to find a way that we can incorporate the velocity into Snell's law. Well, first of all, let's try to rewrite Snell's law. Let's rearrange this a little bit because I want to try to isolate the indices of refraction. So I can rewrite Snell's law to say sine theta 2 divided by sine theta 1 equals the index of refraction of the air divided by the index of refraction of the water. Now, this formula and this formula are the exact same thing. They're just rearranged a little bit. I divided both sides by n2 and then divided both sides by sine theta 1, and I got this. And the reason why I wanted to do that was so I can isolate my indexes of refraction here, because I know that the index of refraction, n, is equal to c. Oops, that's not a c, is it? Boy. Let's try that again, is equal to c divided by v. So I could take c divided by v and swap it for the n in both sides of that equation. So n1 becomes c divided by v1, and n2 becomes c divided by v2. So let me just kind of clean this up a little bit here. Now we have c1, v1. My c's are going to cancel out. So those go away, which simplifies things down a little bit. And my V1 and V2 are actually going to switch positions because V1 is in the denominator of my numerator, which will move that down into the denominator. And V2 is in the denominator of my denominator, which would move that up to the numerator. I know that sounds confusing, but that's just real basic algebra stuff. And when I do all that out, that's going to give me a final form of Snell's law of sine theta 2 divided by sine theta 1 equals V2 divided by V1. Now I have all but one of my variables, and it's the one that I want to solve for. So if I want to rearrange this equation to solve for theta 2, I know theta 2 is going to equal the inverse sine of sine theta 1, sorry, my pen's not behaving really well here, sine theta 1 times V2 divided by V1. I'll plug my values for the angle of incidence and the velocity. Sorry, I got my alarm going off here. Whoops, turn off. This thing always confounds me. There we go. Where was I? Oh, so I'm going to plug my known values into this equation. I have my angle of incidence, the speed of the sound wave in the water, and the speed of the sound wave in the air. And when I do that out, I am going to have an angle of refraction in the water of 67 degrees.